Hello everybody, my name is Mr. Steven and today I'm going to show you how the first topic of Igcse and also applicable in first topic in AS level Cambridge curriculum. So today we are going to see how the number system is. You as a candidate, you have to understand like computer system only understands 0 and 1s. That means binary numbers. We only have two values that can be understood by the computer system, which are zeros and ones. The computer system will never and has never happened that it can understand human language. It is impossible. First, you have to understand in your level, you have to know like how binary numbers and hexadecimal numbers works. Therefore, we'll have to convert binary number to binary number. We have to convert hexadecimal numbers to binary number and together to denary numbers. Denary numbers, we say these are just normal daily life numbers which range from 0 to 9. So we can just have 0, 1, 2, 3 all the way to 9. All of these are denary numbers. I said earlier we have another number which is binary number, which we have only two values, 0 and 1, in which 0 is off and 1 is on. So the computer circuits always run in two states, either on or off. Converting 1, 0, 1, 1, 0, 1 as a binary number to denary, 1 times 32 in bracket plus 0 times 16 in bracket plus 1 times 8 in bracket plus 1 times 4 in bracket plus 0 times 2 in bracket plus 1 times 1. That's when we are getting 32 plus 8 plus 4 plus 1, whereby the answer will be 45 denary. So this is how we convert binary number to denary number. Hey buddy, my name is Mr. Steven and today we are going to see about hexadecimal number system. The aim of introducing hexadecimal numbers is only to shorten the long binary numbers. We have to see how can we convert binary numbers to hexadecimal numbers. Denary numbers and hexadecimal numbers from 0 to 9, they look the same. Like if the denary number is 0, that means the hexadecimal number is 0. If it's 1, and hex is 1. If it's 5, hex is 5. But once the denary number becomes 10, the hexadecimal number will be A. If it is 11, then the hexadecimal number will be letter B. 12 will be letter C, all the way to the rest. Take this example. Let's say we have 1, 0, 1, 1, 1, 1, 0, 0. Now you need to group this binary number into group of 4. Since this is 8-bit binary number, that means we will have two groups, 1, 0, 1, 1. If we place 1, 0, 1, 1 into binary number system, this will give us the value B. The other group will be 1, 1, 0, 0, which means we just have to plus 8 plus 4, which is 12. So 12 in hexadecimal numbers is C. So the answer of this binary number to hexadecimal number will be BC. Hey buddy, this is Mr. Steven and today I'm going to talk about file compression. You as a candidate of Igcse or AS level computer science in Cambridge curriculum, you have to understand what is compression or what is file compression. So file compression is basically simple as reducing a file size so that you can save storage space. You have to understand like in your final paper, they'll have to ask a question in 3 ways on how to compress a file. They will ask you about compressing a text file. They will ask you about compressing a black and white image. And also they'll ask you about compressing a colored image. So you have to get ready with that question. It's a free mark, and you go with me so that we can get into it and understand the concept. So you student, if you want to compress either a text file, colored image, or black and white image, you need to understand the concept of run length encoding. This is an algorithm introduced to compress this kind of file. So to get that question correct, you have to know how the run length encoding works. So get into it that we can dig down into that algorithm. Hey buddy, so today let's see how the run length encoding algorithm works. So let's try to compress a text file. Assume we have text file with a text line like 5 A's, 2 B's, and 4 C's. If we try to use run length encoding algorithm to compress this text file, you just have to compact together all the repeated patterns. For example, we have a repetition of A's, we have repetition of B, and we have repetition of C's. So if we compact them together, that means we have to get 5A, 2B, and 4C. They will trick you in other ways, like they will give a question to compress a text file, but after compression, you'll find out the compressed file size is bigger than the original file size. So one thing that you have to do over there is just to comment that this file cannot be compressed. Hey buddy, let's see how we can compress this text file. Now, in ASCII values, 1 character equals to 1 byte. Now, if you were to find an original file size of this text file, you just have to count the number of characters, then you times by 1 byte. So we have a total of 11 characters, and you just have to times by 1 byte. So this will be equals to 11 bytes. If it was to calculate the compressed file size of this text file, it's 5A, 2B, and 4C. So from this one, 5 is 1 byte, A is 1 byte, all the way to the rest. So we have a total of 6 bytes. So we just have to take 6 characters times 1 byte, which is 6 bytes. So 6 bytes is our compressed file size. Assume you're given a question to compress a text file with a text A, B, C, D. 1 character equals to 1 byte. That means the original file size will be 4 bytes. If you compress this, that means we are just trying to look for the repeating patterns. But now we don't have repeating patterns. That means we'll just have 1A, 1B, 1C, and 1D. We are going to have a total of 8 bytes. Now, if you come across with such kind of a question that you're getting a compressed file size is bigger than the original file size, what you have to do is just to comment like, this file cannot be compressed. Take this example. You are given a question to compress a black and white image. How do we do this with run length encoding algorithm? What do? We have to compact all repeated patterns of black pixels and all repeated patterns of white pixels. Assume 1 pixel equals to 1 byte. You have this example of a black and white image with 3 black pixels and 3 white pixels. That means the original file size of this image is 6 bytes. You can see there's repeating pixels of black and there's repeating pixels of white. We can compress this image by compacting all black pixels and all the white pixels. You just have to write 3 black pixels and 3 white pixels, whereby it has to be written as 3B and 3W. That means B stands for black and W stands for white. If you count all the bytes together, that means you're going to get 4 bytes. Now, original file size we got 6 bytes, but after compressing with run length encoding algorithm, we are getting a compressed file size of 4 bytes. Hey buddy, assume you are given a question to compress a colored image. Now, in compressing of colored image using run length encoding algorithm, you have to understand the components that forms a colored image. In forming a colored image, you need 3 components: the red components, green components, and blue components. A black pixel has 0 components of red, 0 component of blue, and 0 component of green. A white pixel comprises of 255 components of red, 255 components of blue, and 255 components of green. A green pixel comprises of 0 components of red, 255 components of green, and 0 components of blue. A red pixel in colored image comprises of 255 components of red, 0 components of blue, and 0 components of green. Hey buddy, you as Igcse or AS level candidate, you may be asked the types of file compression. We have got 2 types of file compression. One is lossy file compression and lossless file compression. Lossy file compression is the kind of compression that you are unable to revert the file size to its original size after compression. For example, cropping a picture. The second type of compression is lossless file compression. This is the kind of compression that you can compress the file to its smaller size, but you are able to revert the file to its original file size. Hey buddy, so you as an Igcse or AS level Cambridge student, you can be asked in your exam like to add binary numbers. One thing that you have to know is 1 bit plus 1 is 1, 0. That means if you place that in binary number system, you're getting value 2. So if you add 1 plus 1 plus 1, that means you have to get 1, 1. If you place that in binary number system, that means it's a denary number 3. So we have these 2 binary numbers, so we can try to add. We have to start from the right hand side. That means 1 plus 1, we are getting 1, 0. So we just have to write 0 and carry 1. 1 plus 0 plus 1 equals to 0, carry 1. 1 plus 1 plus 0, you have to write 0 and carry 1. 1 plus 1 plus 1 equals to 1, carry 1. 1 plus 0 plus 1 equals to 0, then you carry 1. And lastly, you have to take 1 plus 1, which equals to 1, 0. So you just have to write the full 1, 0. You students, you can take this some number of questions and try on your end and see if you're going to get correct, following the same concept or procedures that we did on this video. Hey buddy, so you as an Igcse or AS level Cambridge student, you can be asked to find a negative binary number. Now, let's say you have a question, let's say show 48 as negative number. That means negative 48. What you just have to do is convert the 48 into binary number system, then invert the binary number. You just have to put 1 whenever there is 0, and you have to put 0 whenever there is 1. So after inverting the binary number, you just have to add 1. So once you add 1, that means you just converted the positive binary number into negative binary number. You can try this question on your end and see if you're going to get the correct answers.